Hi everyone, Big Mac here. I thought I would go over a few of my favorite pre-calculus test questions. So what's going to be going on in this set of videos? Well, basically I'm going to be going over some questions that I actually used in a pre-calculus course for a college level class. So that being said, I'll go over some of the questions, and in future episodes I will go over the solutions as well, and then just some other things as well. So what is this? Like I mentioned, so I have taught college pre-calculus before, so these are actual questions that I used on my midterms. So of course, as a pre-calculus class, it's meant to cover all the things that are important for students to be able to utilize a full semester of calculus, so everything from, polynomial equations to functions, exponents, logarithms, as well as the trigonometry components, the unit circle, your identities, your graphs of functions, all of those things. Of course, this was college pre-calculus, so basically every algebra skill assumed is up through algebra 2, things like factoring, things like plugging things into the quadratic formula, like those are assumed, and I don't spend time on those in class. Of course, sometimes students don't have those skills coming into it, so it is a little harder for them to come and make those skills back up. But again, like what I mentioned, is that I'll present the questions in this video. I won't go into too much detail about them, just what sections were covered on the midterms and stuff like that. And then in future videos, I will provide detailed solutions, as well as just general thoughts on how students did, how students messed up, where common mistakes were. Was it the student's fault? Was it my fault for, maybe wording the question weird? I'll try and go into those details in subsequent videos. So our class had 4 midterms. I decided to pretty much pick 2 from each midterm, and I'm presenting those to you here in these questions. So our first test had basic things like, solving equations, graphing functions, making sure you know how to use your calculator, basic things that you should assume that you should know from Algebra 2 in high school, at the high school level. So for question 1, I asked this simple question. I asked him to find the solution set for this following inequality. I had 1 over h plus 1 minus h over h minus 1, and that whole thing has to be less than or equal to -1. Admittedly, a lot of students had problems on inequalities when they were going over the section, so I made sure that there was one on the exam as well. If you feel like you want to spend some time work out on these videos, go ahead and pause the video or anything else like that. And again, I will be covering these solutions and everything else later on in other videos. That being said, for the second part that I'll cover from test 1, I had some basic true-false questions that I think really helped identify certain weak points or, thinking and other weak points that students might have in their thinking. So I actually had a number of other statements, but these are just 3 that I picked that I thought were really important. So the first one, if we have the product of x to the 7th minus 3y and 10x plus y to the 6th, if we have the product of those 2 terms, and that has to equal 12, then true or false, do we know that either the first term is equal to 12, or the second term, 10x plus y to the 6th, is equal to 12? Our second statement was that for all values of x, is it true that 2 times 4 to the x is equal to 8 to the x? So again, these are things that students had calculators to use on. These are things that they could have spent some time looking at and evaluating, or they could have, if they just instantly knew the answer, of course they could just do true false. I did not require them to, disprove disprove their answer or anything like that, or to correct the statement if it were false. I was just asking, is it true or is it false? Like, these were just pretty straight, just a couple of points each, just making sure that students had the basic understanding of what's going on here. So this last one, the solution set, again we have another inequality, x squared greater than 49. It's the union of 2 sets. We have x is greater than -7, so we have from -7 to infinity, and x is going from 7 to infinity. Is that the solution set for this inequality? Going to test number 2, we started talking about more formal notations for things like functions, as well as talking about polynomials, their graphs, finding number of zeros, polynomial division, those kinds of things. So we have this set of questions regarding function notation. We have 2 functions, f of x and g of x. G of x is x to the 5th plus x cubed plus 10. I mentioned that it is a 1-to-1 function, and that it has a domain of just 0 to 8 inclusive. Our second function, f of x, is just the square root of 16 minus x squared. So this was actually a 3-part question, and admittedly students did better on some parts than others. So first part, what is the domain of the product of these two functions, f of x times g of x? Students learn over the course of the semester that this is the notation for the product of these two functions. Secondly, what if we wanted to evaluate f of x? What is that going to look like in terms of our final answer? How will that end up looking? Will it be a function of x? Will it be a constant? Is our function invertible? Things like this is what we want to try and figure out. So part C, I asked students to evaluate g inverse of g of 2. I mentioned to students, don't spend a whole lot of time on this section. Please don't spend a whole lot of time thinking about that equation. So the other question that I included from chapter 2, or not chapter 2, but just test number 2 in general, was a multiple choice question. So of course I had a handful of true and false, short answer, multiple choice, basically different things for students to try and figure out help them realize what they know and what they thought they knew, but actually don't. So suppose we have a quadratic function, y equals ax squared plus bx plus c. So my question was, which of these represents the y-coordinate of the vertex point? So obviously this is a quadratic function, so it'll have some vertex. What is the y-coordinate of that vertex? Of course, it will be in terms of a, b, and c. So, of course, I have 4 choices here. Some of them might look more familiar than others, but it's up to students to determine which of those represents the y-coordinate. For test number 3, we actually started doing a little more work with trigonometry, as well as just a short section on exponential functions, logarithms, things like that. So I had here I think a pretty straightforward right triangle problem. So the math magician, floating 20 feet above the stage, is ready for his final act. 2 spotlights, a total distance 40 feet apart from each other, point up towards the magician. So the angle of spotlight A happens to measure 53 degrees. What's the measure of angle B? So again, you would be expected to use some basic right triangle trigonometry. You can use a calculator if you wanted, hence SOHCAHTOA, those kinds of acronyms and stuff like that. So at this point, it's just trying to figure out what the other angle happens to be for angle B. Again, like I mentioned, we had some work with exponential functions and logarithms, stuff like that. So I asked people to solve the following equations. I had a handful, and these were 2 of my favorites. So, and I also mentioned do not approximate the answers because I don't want just a string of decimals. Because, that doesn't really tell me anything about how you actually solve the equation. That's telling me how your calculator solved the equation. So we have 7 to the x is equal to 7 to the 0 power plus 7 to the first power plus 7 squared. So if you have to leave your things in terms of square roots and logarithms and things like that, that's perfectly fine. Our second equation, we have x cubed e to the x minus 9x e to the x equaling 0. Lastly, for our 4th midterm, we talked about more straight-up trigonometry. We talked about the unit circle, trig identities, inverse trig functions, all of these important things that will be popping up during the regular course in calculus. So I had a series of true-false questions again on this test. So for our first one, if we took the sine of the inverse tangent of x, for x being from 0 to pi over 2, is that the same as the cosine of x? True or false? Speaking of inverse functions, if we took the inverse cosine of root 3 over 2, is it true or false that we get 0.52359877756 as our answer? Our third case is if we have the cosine of the inverse cosine of 5 pi over 4, that is just 5 pi over 4 again. Right? True or false? Lastly, for last question that I'm going to cover in this intro video, just a longer word problem involving certain functions. So suppose the temperature on a hot day was modeled by this function. We have 85 minus 15 cosine of pi over 8 times t, where t is the number of hours since 7 a.m. So, of course, our first question, what's going to be the maximum temperature for the day? I also asked what time of day did it occur, and by time of day, I don't just mean, at t equals 2. I mean, was it 9:30 in the morning? Was it 2:30 in the afternoon? Was it 4 o'clock in the afternoon? 4 o'clock in the afternoon, something like that. So question B, following that same idea, when did the temperature first hit 92 degrees? And I said it was okay for students to round to the nearest quarter hour. Of course, I expected them to show their work in order to get full credit, because you can just graph it, see where the intercept is 92, and that doesn't tell me that you understand what's going on. That tells me that you know how to use your calculator, which is useful in itself, but not what I'm testing on. Okay, and then I asked part C, is this a good model to continue using into the night and into the next day? Provide an explanation to why or why not. Will this function continue to be useful? Will it not be continue to be useful? Give some kind of a formal explanation in terms of the equation itself, not just, because the weather might change tomorrow. Something a little more quantitative based on the function itself. So these are just some of the questions that I use on an actual midterm course, or actual midterms in my course in pre-calculus. So in subsequent videos, I'm not sure how often I'll be releasing these, but in subsequent videos I will go over detailed solutions and everything else like that. Until then, this is Big Mac saying, later.